These particles will react into two charges. One is a positive charge, the other a negative charge. In this lesson, we're going to discuss charged bodies. The reaction of the particles indicate that a field exists between the charges. This field is an electrostatic field. In this discussion, we'll find out how the materials become charged, the effect that two charges have on each other, and we'll discuss the electrostatic field that caused the particles to react. You've seen the effect of charged materials many times. One example is running a comb through your hair or rubbing it with some material such as, say, fur or wool. And the comb then picks up bits of paper. Or perhaps a balloon that magically sticks to the wall after you've rubbed it on your clothing. Or perhaps you recall an occasion of sliding across a car seat, reaching for the door handle, and zap, you received a shock. In each example, the reaction occurs due to materials possessing different charges. Now, what do we mean by a charged material? Well, remember, all materials are made up of protons and electrons. The atom may be neutral, a positive ion, or a negative ion. It's neutral when it has the same number of protons and electrons. If some force causes the atom to lose an electron, it becomes a positive ion. It's left with more protons. However, if the atom gains an additional electron, it becomes a negative ion. In either case, the material is considered to be charged. Now, there are several ways of developing a charge on a material. One way is by using friction. For example, if this rubber rod is rubbed with fur, it will become charged. It becomes charged because the energy level of the electrons will be raised, and they'll either leave the rod or enter it, depending on the material used to produce the friction. Now, if the rubber gains or loses electrons, it's acquired a charge. Now, notice how a neutral body reacts to the rubber rod. This indicates that the rod is charged. The neutral body in this case is a pith ball. Now, pith is a soft, spongy core in the center of certain plants. And I'll use it throughout this discussion because of its ability to acquire charge, to hold a charge, and to react readily to other charged bodies. Now, another way to charge an object is by the conduction method. Now, in this, I'll again use the rubber rod, and I'll charge it with the fur. This time, when I bring it to the pith ball, I'll let the pith ball touch it. The pith ball will acquire the charge in the rod. So in the conduction method, the objects must touch. Conduction means electrons traveling through one object to another. Another method of charging an object is by induction. Now, to show this method, I'll use a pith ball, a glass rod in this case, and an electrical voltage source. Now, the source that I'll be using is very dangerous, so as a safety measure, I'll use this insulating rod to handle the voltage. Notice that the pith ball isn't reacting to the glass rod, so there's no charge on it. Now, I'll bring the voltage source in to the other end of the rod, but I'm not going to touch it. Now, watch what happens when the glass rod becomes charged. The pith ball is attracted to it, but why? Well, the charge from the source is creating a force which causes the free electrons in the rod to pile up on one end. The end that gains electrons will be negative, and the pith ball is reacting to this negative buildup. In other words, the electrons in the rod have been induced to move by the charge of the source. Charging by induction. Okay, turn off the voltage source. Okay, it's off. The three methods of charging then are by friction, conduction, and induction. The most practical means are induction and conduction, but in some cases friction can develop a tremendous charge. Lightning is an example. When warm and cool air come together, there's a tremendous amount of friction developed, and a very large voltage. Now, the largest arc developed by man was 50 feet, and it took 30 million volts to do that. Imagine how much voltage is developed in a thunderstorm when lightning jumps a mile or more. Now, when objects acquire charge, the shape of the material determines how the charge is distributed. For example, when the charge builds up between these plates, it's distributed along the surface of the plates. Now, this is true also on a sphere. The charge is uniformly distributed over the entire surface. But in objects with irregular shapes, the charge is concentrated on the area of greatest curvature, or at the sharpest point. Now, we've seen how an object acquires a charge. Let's determine the effect that two charges have on each other. Now, to demonstrate this, I'll use two pith balls suspended on strings. In the first example, I'll use the electrical source to place a positive charge on one pith ball, a negative charge on the other. Okay, turn on the power source.
It's on.
Bringing in the positive charge, notice that the pith balls are drawn together. Therefore, we can say that bodies with unlike charges attract. Now, the pith balls fell apart because the charge is neutralized. So, trying it again, positive on one, negative on the other, the pith balls attract. Remember then, a negative and a positive or unlike charges attract. Okay, turn off the power source.
Power's off.
Now, I'm going to remove one side of the power source and connect a jumper between the two rods. In other words, what I'm going to do now is place like charges on the pith balls and check the reaction. Turn on the voltage.
It's on.
Now, applying like charges to the pith balls, notice that they repel. Then we can say that objects with like charges do repel. Okay, turn off the power supply.
All right, the power's off.
Now, in this demonstration, the attraction and repulsion occurred because an electrostatic field is developed between the charged bodies. Now, don't let the term electrostatic field throw you. It's nothing more than the unseen force about a charged body. We can determine what the field is by using the demonstration we saw at the beginning of the lesson. Now, I'll place a positive charge on one metal plate and a negative on the other, and there should be a force of attraction. Now, to see the electrostatic field that creates the attraction, I've put some small light particles between the plates. Now, as the charge develops, notice the reaction of the particles. They tend to gather and form lines between the plates. Now, these are the electrostatic lines. It's the force that's developed between charged bodies. Now, the strength of this field is determined by the amount of charge on each body and the distance separating them. This formula shows the relationship of the distance and the charge on two bodies. For example, if we increase d, the distance between two charges, the force will decrease. If we increase q, the charge on the body, the force will increase. Now, here are some terms associated with charged bodies that you should become familiar with. A coulomb, for example, is a measure of the amount of charge. Electrostatic unit is also a means of measuring the charge on a body, while dyne is the unit expressing the amount of force between two charged bodies. Now, make sure that you understand how a charge is developed and the laws of attraction and repulsion. These are very important laws, laws that form the basic principle of operation for all electronic circuits. In our next discussion, we'll apply these laws to develop a better understanding of practical electronics.